Hi everyone. To continue our discussion, we will go on Module 2, Unit 1, using data types and units. A notational system is used to represent different quantities or characters such as decimal, binary, and hexadecimal. For most people around the world, when they want to count something, they use a decimal. The decimal system or the base 10 is so well to understood. It's actually quite easy to overlook how it actually works. Decimal is based on the principle of expressing 10 different numbers using a single digit range from 0 to 9. While people find decimal easy to use, computers use binary to calculate and process information. They called it a binary. Binary is a numbering system where each single digit can express only two values in the range of 0 to 1. Binary can also be referred as base 2. For example, the number 51 in decimal can be expressed in binary as 110011. So how do we convert that? As you can see, each column is worth the base number 2 times more than the preceding column, as well as move from least to most significant, which is your right to left. Thus, the second column is worth twice the first. Like for example, 1, 2, 4, 8, 16, 32, 64, 128, 256, so on and so forth. You can express large number more efficiently by using hexadecimal, often shortened to hex. The hex notation system enables you to express 16 different numbers using a single digit in the range of 0 to F. We have 0 to 9, and if it is 10, 10 become A, B is 11, C is 12, D is 13, E is 14, and F is 15. For example, the number 1, 2, 3, 4 in decimal, so 1234 in decimal, can be expressed in hexadecimal or hex as 4D2. So how do we do that? In this notation, the letters A through F are used to express numbers larger than 9, which required 2 digits of decimal to express. As I have said earlier, A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So the rightmost is 1, and then multiply it by 16 times larger than your first value, and then multiply it again. It becomes 256, and then multiply it again, and it became 496. So to compute the 1234 in decimal, so you need 4, 256, you have 13, and you have number 2. To get the value, you have to multiply the 256 times 4, 16 times 13, which is represented by the letter D, and 2 multiplied by 1. So you add the answer and you will get the 1234 in decimal. But in hexadecimal, it represents as 4D2. For the units of measure, the basic unit of computer data is the binary digit or a bit, which is represent two values, which is your 0 and 1, or you can use a 0 or 1. Computer memory and file sizes in Windows are measured in multiple bits. The first multiple is the byte, which consists of 8 bits. A double byte is 16 bits. So another, for the units of measure, for example, we have kilobyte. Approximately that is a 1000 bytes. Small files are often measured in KB. Megabytes or the MB. Many files would be measured in megabytes. For example, your MP3s measured as megabyte. Gigabyte or your GB. Gigabytes are usually used to talk about disk capacity. Most of the movies today have a gigabyte sizes. Next is terabyte, approximately 1000 GB. Some individual disk unit might be 1 or 2 terabyte, but these units are usually used to describe large storage networks. Petabyte or PB, approximately 1000 terabytes or 10 to the power of 15 bytes. The largest storage network and cloud system would have petabytes of capacity. You should also be aware that different system of notation is available to describe these multiple binary terms, or yung these two, where the multiples express powers of 2 rather than the powers of 10. Like for example, KB byte, KIB, 1024 bytes, so 2 to the power of 10. Megabytes, 1024 multiplied by 1024 bytes, or equal to 1,048,576 bytes. Or the GB byte equal to 1,073,741,824 bytes. When data is transferred between components in the computer or between computers over the network, the throughput rate that a particular connection can sustain is measured by bits per second, your BPS, such as kbps, your 1000 bits per second. Mbps is 1 million bits per second. Gigabyte is 1 billion bits per second, and TBPS is 1 trillion bits per second. While throughput rates describe how much data is transferred over the link, the speed at which a computer works can also be described independently of how data is involved in each operation. So for the processing speed, you got megahertz, 1 million cycles per second, that is megahertz. Gigahertz is 1000 million or 1 billion cycle per second. So that is for the processing speed. For the data types, it is important to understand the different data types that a computer program can use. This is especially important when you start to write your own programs or your coding or work with database system. Boolean values. These are specific numeric data type indicating that something is either true or false or 1 and 0. And it only consumes single bit of storage. Characters or char is a single textual character and can be a letter, floating point numbers. This type can support decimal fraction such as or decimal places such as 4.1, 26.4 or 5.62. A floating point number or just the float consumes 4 to 8 bytes of storage. Boolean values. These are specific numeric data type indicating that something is either true or false or 1 and 0, and it only consumes single bit of storage. Characters or char is a single textual character and can be a letter of the alphabet, a symbol, or indeed a numerical character. For example, A, D, 7, $sign, @ hashtag. This consumes a 1 byte of storage. Strings. A string is a collection of text characters. For example, XYZ, hello world. Those are the example of strings because